Today, we're going to be using Blender to color outside the lines. Let's figure out how we're going to spread the color from this line over the rest of our page. One basic strategy would be to take the nearest point on the line and just use that to color in the plane. But if we do that, we get this kind of sharp line through the middle of our page. At first it seems like we can just blur our plane, but unfortunately that doesn't work. If we look up a little bit, we realize that those sharp lines actually persist way out to infinity. If we increase the blur enough out here to look good, then when we look back down, it's way too blurry down here. The solution is going to be to take multiple samples of our curve at every point. If we take them at fixed directions, then we'll get something that looks a bit like this. This might be a cool effect for some things, but it's not smooth, and so it's not the solution we're looking for. We're going to use a sampling strategy that is statistically equivalent to Brownian motion. The first step is to draw a circle as big as you can until it touches the surface that you're trying to sample. The next step is to randomly pick a point on that circle and step there, and then repeat that until you come close enough to the curve and then sample the color of the curve there. Sometimes it can take quite a few steps to actually reach the curve, so we need to make sure that our algorithm will take enough steps. And to get a nice smooth result, we have to repeat this process from scratch many times for each individual point. Nice thing about this process is that we can actually go outside of the curve as well, and we'll still get really nice smooth results. We do need to take a lot of samples though. If I reduce this render from like 2000 samples all the way down to say 20, you can really see how we need to take a lot of samples for this to work. The other cool thing is that we can take steps on spheres instead of circles to extend this technique into 3D, and that's what I'll be demonstrating using geometry nodes next. First, go ahead and delete that default cube, head up to File, Import, OBJ, and let's grab a copy of the Stanford bunny. Zoom in a little because he's really small, hit Tab to edit, and scale him up a bit. Hit Shift A and add ourselves an icosphere, position it above his head, and go to Mesh, Normals, and Flip. Now if we visualize the normals, we can see them poking out of the bunny, but they're actually poking inwards into the sphere. Hit Tab to go back to Object Mode, and let's create a second object. This will be the bounding volume for the effect that we're going to create. To keep our lives simple later, select each object and hit Ctrl A to apply all transformations. Head over to Modifiers, and with the cube selected, let's add a Geometry Nodes modifier. Switch over to the Geometry Nodes editing workspace. We'll get started with a Mesh to Volume node, and then we'll add a Distribute Points in Volume. We'll change that to Mesh mode and use a Value node to set all of the spacing at the same time. Next, we'll add in a few stored attributes. We'll start with one called original_position, which will be of type vector. And while we're here, I will drag the position node into its input. Next, we're going to do another vector attribute called sample_accumulator. We're going to add an integer attribute called sample_count, and an integer attribute called probe_step. Now if we head up to the spreadsheet, we can see they're all showing up here. To get some Brownian motion going, we're going to add ourselves a repeat zone, connect the input and output of the repeat zone to our geometry stream, and the first thing we're going to add is something to help us generate random numbers. Drag open the side panel, add a new integer attribute, and change its name to random seed. Drag it into our repeat zone, and let's add an add node, and we'll set the second value to 1. I might just rename that to increment while we're here, and make sure that it's connected to the output as well. We need a random unit vector. We're going to drag our seed down, select random value, choose the vector type so that we get 3 random values. We'll set the top one to vary between 0 and tau, and the second one to vary between -1 and 1. From the top one, we're going to extract a cosine node, a sine node, and from the bottom one, we're going to grab an arc cosine node. Also add another sine node onto the end of that. Then we're going to create 2 multiply nodes and connect them up as shown. We'll connect those all together in a combine XYZ, and I'll name the group random 3D vector. Let's go ahead and create a set position node, and we'll apply that random vector to the offset input. Now we can increase the iterations on our repeat zone and it looks like flies buzzing around his head. We need to make it so these random offsets have a specific length. The length of each step will be the distance from the point's current location to the nearest point on the bunny mesh, but still in a random direction. So pull the bunny into our geometry nodes, grab the geometry socket, and grab a sample nearest surface node. Set the sample type to vector, and plug position into the value socket, and also plug position into the sample position. If that's confusing, well, maybe it'll make sense later. Grab the output of that node, subtract it from the position. After that, link it to a length node, use a scale node to apply the length to our random 3D vector. Use this to replace the input to our set position offset socket. Now when testing, we see that some points move closer and closer to the bunny and then eventually get stuck on his face. That's when we actually want to take a sample. We'll grab this length over here and we'll check when it's really small. When it is, we're going to use this store named attribute node to update our sample accumulator. Make sure the type is set to vector, and to create our actual sample value, we'll drag in another copy of the bunny. We'll use another sample nearest surface node. Again, set the data type to vector. Next, drag out the value socket and select the normal node. This can be any vector, but for now, we'll sample the normal of the bunny as our attribute of interest. Into the sample position, use another position node, and again, if you find that confusing, maybe it's making more sense now. Currently, the sample accumulator would be replaced every iteration, so let's grab the existing value of the sample accumulator with a named attribute node, and we'll use an add node to combine those before we store it again. Now, whenever we take a sample, we need to increment the sample count. That will allow us to take an average at the end. So let's create another store named attribute node and another named attribute node, and just add 1 to the sample count every time. We can use our same Boolean value from before to make sure that this only happens when we actually took a sample. Whenever we complete a sample, we want to reset the position of the point. Let's use a set position node and retrieve the original _position attribute, and we'll plug in our Boolean check to make sure that only happens when it's supposed to. If we expand our spreadsheet a little bit and scroll back over to our repeat block, let's increase the iterations and see what happens. Now, the points aren't getting stuck on the bunny's face because we're resetting the position, but we have another problem. Some of the points are just buggering off to the edge of the universe. To prevent that, we will track the number of steps taken by each point, and if it takes too many without hitting our mesh, we'll just reset the position without taking a sample. And much like before, we'll retrieve the existing value of the probe_step attribute, add 1 to it, and then store it back onto our geometry. Next, we need to make a bit more room before the set position node so that we can add 2 things. First, a check to see if the number of steps exceeds, say, 25. And we'll use an OR node to combine that with our existing condition and plug it back into our set position node. Next, we'll reset our probe step attribute to 0, but using the same conditional check as the set position node. Just in case, let's also check our distance away from the bunny. We can grab our length from back over on the left here, and if it ever gets more than, say, 3 units away, then we will also reset our points. So we'll add another OR node just here. And that's everything we need for the repeat zone. We'll calculate the average value of our sample accumulator, just divide it by our sample count and store it back into the sample accumulator attribute. We can reset our points back to their original position using the original position attribute. And at this point, there are many creative directions we could take, but let's just go for a quick preview. Let's create a circle mesh, make sure that it's filled with triangles, and create an instance on points node. Drag the rotation input out, and select an align rotation to vector node. And we'll use our sample accumulator value to set the rotation of these instances. Initially, our results don't look that interesting, and that's because our sample count is way too low. We need to scroll way back over to the beginning of our repeat zone, and let's try 200 iterations, more like 1,000 iterations. That's much better, but before I do a close-up, let's add a bake node just after the repeat zone. That'll speed things up while we're doing a preview. I've increased the number of points and the size of the circles, And now we can really get a sense of this smoothly interpolated normal field around the bunny. You'll notice how the field flips direction above the bunny's face as it's going outwards from the bunny and inward towards the sphere, because we flipped the sphere's normals at the start. At some point during all of that, Blender crashed, and some absolute champion from the Blender chat helped me to actually compile it so I could report the bug. Now, you should make sure that you're using the latest version of Blender and everything should be fine for you. I didn't actually fix the bug myself, but I made some upgrades since I had it compiled. Why not? Like, I've graffitied the beautiful artwork there, sorry. Don't mean any disrespect. I love the splash screen, but I've stuck my face on it. And then in geometry nodes, I've added a whole new node. It's called Nix Input String. It has a really special output. What does it do? Would you look at that? Thank you so much for watching. Here are a couple of effects that I came up with. I've got the bunny with these coins that are kind of following that normal field that I showed you how to create. And then here's Suzanne, where I've kind of taken the true normal of the monkey's face and compared that to a smooth normal at a certain distance. And that gives you this kind of tangent effect. You can find the movement along the surface. Anyway, thank you very much. Hope you enjoyed. See you in the next one. Bye.